Hello everyone, a very warm welcome into this webinar. With the second wave of lockdown going on, I hope everyone in your family, in your relatives, friends, colleagues, all are safe. I welcome you to the 43rd episode of the Net Zero Energy Building Knowledge Series. This is a platform for industry to share expertise, projects, products, technologies, research, and ideas to fuel discussion on the energy efficiency and grow engagements for the net zero energy efficiency buildings in India. I am Anval. I'm working as a green building analyst at Environmental Design Solutions, and I shall be the session moderator today. The webinar series is executed under the MATRI program supported by USAID. MATRI is an acronym for Market Integration and Transformation for Energy Efficiency. MATRI supports three main program areas, which are energy efficiency in buildings, sustainable cooling, and training and consumer engagement. MATRI supports. The program works in partnership with several organizations such as Energy Efficiency Services Limited, Bureau of Energy Efficiency, and others to implement various initiatives. The market transformation approach includes creating business opportunities for the private sector, scale up of the potential initiatives, enabling policies, as well as providing training for NZEBs. MATRI is supporting effort moving towards a super efficient and net zero energy target for buildings in India. The NZEB knowledge portal is a one-step site. For the information on NZEBs, you may explore this further on the website .nzeb.in. Our webinar today is about the showcase of a net positive residential project development called HUMANSCAPES. It's a net positive energy experiment housing complex in Auroville, India. This is a climate responsive and built with low embodied energy material like locally sourced clay and natural stone. The project aimed to be used as a prototype into creating future developments that can withstand the impact of climate change. Let's learn about them from the architect herself, Suhasini Iyer, who is the expert speaker for today's session.
Hello.
She leads the Auroville Design Consultant, a planning and an architectural design studio, primarily focused on planning, designing, and implementing the applied research development projects within the Auroville to field test the innovation and research carried by CSR and the other organizations within the Auroville. She is also the co-founder of the Auroville Center for Scientific Research Trust, the CSR. It's a collaborative organization with multiple agents and agencies working in the area of applied research in sustainable settlement, planning, solar passive architecture, appropriate building materials and technologies, water and waste management, and renewable energy. Welcome to the webinar, Suhasini. We look forward to learn more about the project from you.
Thank you. Hello, everyone. I'm really honored to be presenting on the platform that EDS has set up for professionals to share and exchange ideas on energy efficient buildings and zero energy development. I'm going to start with presenting a few of the things that we do as a studio, and then move on to the project itself. So just hold on, I'll share my screen. Here we are. Is it visible? Hello?
Yes, it is visible. Yes.
Okay, thank you. So as part of the knowledge series, I'm going to be presenting one of the projects that we have done in the recent past. It's called HUMANSCAPES Habitat. It was undertaken as an applied research and demonstration project for sustainable and integrated urban living. To give you an idea of our studio, we are the Auroville Design Consultants. It's an architecture and planning studio. We have very a holistic group of people that are loosely connected to each other under a trust called Auroville Center for Scientific Research, under the Auroville Foundation. Now, Auroville Foundation is an autonomous body created by an act of parliament. It is situated 12 kilometers north of Pondicherry, and there are about 3,700 residents from 52 different countries of the world. The intention behind the project, the larger project of Auroville, is to create an urban settlement of 50,000 or more people devoted to a certain research in integrated living based on the philosophy of Mother and Sri Aurobindo. My studio is part of a multidisciplinary organization where we work in several fields. One is, of course, the planning and architecture. We have Aurora, which works with renewable energies, which is wind, solar, and biomass. We also do a lot of applied research and consultancy in water resource management, which is sewage treatment, and surface water management, and sustainable multi-sourcing of rainwater, potable water. And besides that, of course, we work with integrated transport systems and solid waste management. Some of the projects that, our guiding principle of my studio in the larger organization is that we believe that beauty and harmony is essential for healthy living. And unless you have beauty and harmony as an essential part, you cannot really have a sustainable built environment. The second principle that we have is minimalism. And here I'm not talking about minimalism in terms of forms, but actually minimalism in terms of a concept of integrated, sustainable, and green building practices. We work with active and informed participations with our clients. So we go through a whole process of mutual education and communication before we start with the design process, so that at the end of the day, it's not just a product that we leave them with, but we actually make it into a partnership of learning. The last but not the least, which is the core efficiency that we are looking at, is the context responsiveness, where whatever development we undertake, whether it responds to geography, climate, functional efficiency, building materials and technology, skill development, and cost effectiveness. Some of the projects that we have been doing, the studio has been around now more than 3 decades. We have done the Auroville Visitor Center, which was one of the first public buildings in southern India in compressed earth blocks. And for almost a decade, it was standalone in terms of energy and water and sewage. We were treating the sewage on site, and that was the only water used in the landscaping. We have also undertaken and implemented a solar thermal project, which has a fixed solar thermal device cooking food for 1,000 people each mealtime. This was completed almost 2 decades ago, a little more than 2 decades ago. We have also been working with recycling of waste as the primary building material. So this is an institutional building that we have done in Auroville again. And we also do a lot of public buildings using earth as a primary building material. And most of the products that go into the building is non-industrialized products. Now, coming to the main part of the talk, I'm going to talk about the HUMANSCAPES Habitat project. It is a case study, for me at least, as where design becomes a process rather than a product. where you just go out with a set of skills and you implement it. So the intention of the project when we started it was to first set benchmarks. We did that by inviting people with experience and people with knowledge to a one-day workshop and went through several parts of the National Building Code and looking at what are the responses we can come up with to make something that has a new benchmark for a harmonious development, and thereby addressing the present global crisis of energy and climate change. Especially for India, the crisis of energy is a very important point to address. We also looked at how to create an environmental and social balance with mixed-use development of residences, community, and workspaces, and how the building design and construction materials and how the labor would be used would address the issue of skill development in the construction industry. Because as all of us have experienced a year ago and are again looking at it, a large part of the unorganized sector employment in this country is with distressed migrants, not aspirational migrants in India, who are employed in the construction industry, where there's no investment being done in skill development. They're rather used as just a component of converting the material into a finished product. And last but not least, how to reduce construction waste in the habitat sector to meet India's commitment to the IPCC. So with these intentions, we fixed some project goals. Some of these goals were quite simple, straightforward. Many of you work with these goals, which is integrated environmental planning, where water, energy, waste cycles are closed, with zero discharge of water and reduction and recycling of solid waste, water efficient landscaping, and local endemic species and urban agriculture. Second goal was sustainable built environment with solar passive building design coupled with efficient functional spaces, so that we reduce the built up space and we use low embodied energy building materials. Third was, of course, addressing the mobility component, where work from home and integration of living and working spaces. And it's amazing because we started working on this in 2014-15 to look at how living and working spaces could be integrated more with a better network of ITC and allowing for clean mobility options with social functions also mixed in. So in a way, the project actually, we could do a test run when the first lockdown happened a year ago to see how we could operate from home. The fourth aspect was the human ecology, which is, I mean, all the other things are kind of technological and inputs with, external factors that impact the lifestyle of people. But without the cooperation of the people, how do you actually make a change towards a sustainable living pattern? So we looked at how to work with co-housing concept of living, how to facilitate interaction among neighbors for an inclusive socio-economic development that will lead to environmental benefits. And last but not least, and this is why we are here on the EDS knowledge platform, is to establish a collaborative network of knowledge resources so that we start interlinking with other institutional knowledge sharing and dissemination platforms to not only share what we have done, but to also learn from their experiences to be able to take this project as a constant learning platform. So starting with the Sustainable Development Goals, as most of you are aware of, India has signed up for the Sustainable Development Goals, 17 of them. And based on the benchmarks we set with the professionals, we addressed about 10 of them, which are these: health and well-being, water and sanitation, affordable and clean energy, decent work, and economic growth, industry, innovation, and infrastructure, sustainable cities and communities, responsible consumption and production, climate action, life on land, partnership with goals. So taking this into account, the project is in various phases. What I'm going to show you is the first and second phase that we have already completed and it's occupied. The project is called HUMANSCAPES because we wanted to actually do an integrated applied research between the built and the unbuilt environment, between the physical and the human geography, between energy, waste, and other cycles, and the socio-economic cycles. So moving on, so we had set goals and actions in various sectors: land, water, climate, building, energy, waste, and lifestyle. When it came to land, we looked at three principles: minimum disturbance natural topography, retained indigenous trees, secure topsoil from areas to be built to ensure fertility is retained to respread when the construction is done. And when we dealt with water, was integrating flow channels, retain high percolation areas as no-bill zones, creating bioswales and collection ponds for surface and roof runoff to supply potable water, wet area designed for low water use and low fixtures. And this is how we did. We looked at the site, the natural topography that was there, natural to the sense that it was, of course, an agricultural field before, and there was disturbance to the natural topography over the last 3-4 centuries with the degradation of the land, deforestation, rain-fed agriculture. So the land that was allocated by the Auroville Planning Group to us, we mapped it. We mapped the topography, the trees, the porosity of the soil, and retained as much as possible the natural flow of water. Based on that, what we did was we came up with what we call a bioswale, which is here, and looked at all the different micro drainage patterns once the buildings would be introduced, and to see how we collect the rainwater in different areas and channel them in such a manner that finally the ecological corridor as a filtering mechanism would allow these bioswales to fill up, because Auroville is in an area which has very heavy rainfalls in very short durations. So we could have 20-25 centimeter of rainfall over a period of 6-7 hours. So no matter how good the percolation of your soil is, it goes beyond the percolation capacity. So why are we making these bioswales? What we are going to try to do, and we are working on this project right now, this part of the project is done, and we are working on this now, is to actually create these bioswales in a manner that after shaping them, having gravel beds and planted plants to slow down the water, collect the water, and hold the water, so that we can actually re-establish the soil moisture. While I'm going back here, and if you look here, we have proposed some open wells. And the idea is actually to use the bioswale where the soil filters the water and moves towards these open wells, from which, using a DC pump with solar panels, we can actually pump out potable water. So that means we instead of holding it in concrete underground tanks or any kind of HDPE tanks, we actually use the land itself as a filter and holding mechanism, and use the open wells, which are maybe about 20-25 feet deep, and repump back the water. We are doing this actually with Integrated Design, a company in Bangalore. Most of you must be familiar with them. And the end result would be, we have a landscape space that during the summer would be dry, most probably, but you would still have subsoil water, which we could continue to pumping. This creates a multi-sourcing of water, because presently Auroville is completely dependent on the groundwater sources through bore wells for supplying all our potable water needs. And this groundwater source is not only falling rapidly, but along the coast it's getting salinated. So we're looking at various options of multi-sourcing of potable water, and this is one of the options that we're working on. So to be able to then fill these bioswales and ponds, the buildings have been designed to collect all the roof runoff through various overhangs, channels, gutters, and channel them into holding tanks, which act as sunken coats during the dry season, and which then overflow into further channels that then fill the bioswale. So it's like several steps of holding, collecting, slowing, and then overflowing, so that by the time it reaches the bioswale, it has created a certain sponge effect with the grasses and the shrubs and the root system that holds the water even when the surface water starts to dry off. Because the water holding capacity of the soil, when it has the right size plants, is incredible, and you don't have so much evaporative loss then. To be able to collect the rainwater and to start using it as a secondary source of water is great, but we also looked at how do we reduce water consumption. Of course, the end of the pipeline solution, which is very popular, is low consumption taps, low flush toilets, and stuff like that. But what we realize is that reduces the water consumption only at certain points. But other areas of water consumption, which is water that is used for cleaning, like in bathrooms where you have ceramic tiles, which are not only high embodied energy, but they tend to have such a impeccable finish that unless you have water which is highly softened, you're going to use a lot of water to keep them sparkling clean. So we started working a lot with what is called IPS, Indian Patent Stone, which is basically cement finish with oxides and marble dust to produce impervious walls, which act as instead of tiles, these walls act as your impervious walls in your shower and shower areas, in kitchen dados. Use of only natural stone for the floor so that the amount of water used in floor washing is reduced. And finally, of course, using the principle of minimum water use by ventilating and lighting the toilets in such a way that they always remain dry and smell free, and therefore psychologically enabling people to use much less water as a cleansing mechanism. Because whenever we use water as a cleansing mechanism, basically what we're doing is using water as a diluting mechanism to clean. So, for example, when you flush a toilet, for 100 grams of human feces, even with a low flush toilet of 2 liters, you're basically diluting it to put it in the pipelines to send it somewhere for treatment. So as much as possible to reduce the need of water as a cleansing mechanism with surfaces, right type of temperature in the rooms, light, ventilation. We are also in the main spaces of the house used only natural stones or IPS as flooring, so that you do not have the need to start washing your floor, which is culturally a done practice in South India for some reason. People like to wash their floors and walls with tons of water so that it feels clean. So using these kind of floors, we try to put in a psychological mechanism of not wanting to wash the floors, which happens with a lot of the ceramic tile flooring. Coming next to the climate, what we have tried to do is, of course, coastal Tamil Nadu, which is where the project is, has very low wind speed with seasonal cyclones that are very destructive. Now, the problem is when you're living along the coast, you have a high relative humidity. So temperatures in the summer very rarely goes above 40 degrees centigrade. But because of the high humidity, the perceived temperature is worse than 45 degrees in a composite climate like Delhi. So we have to work with lower temperature, but because of higher humidity, the challenge of building in coastal climates is much more than in a composite climate or a continental climate. So the daytime temperature is most of the year, 10 out of 12 months is above 30 degrees centigrade, and the relative humidity is above 60 degrees, no, 60%, sorry. So we looked at different issues, which was, of course, orientation to have the least solar gain. We looked at orientation to harvest maximum amount of ventilation, because we have the day breeze and the night breeze because of the coastal region, where with the difference of temperature between the land and the sea, the wind moves different, wind direction changes during the day and night. And of course, the solar part. Taking that into account, we laid out the buildings in such a way that we created higher wind shadow. And this creates a negative pressure behind the buildings, allowing the increase of wind speed within the building. So when the incidence of airflow is at 45 degrees to the aperture, what happens is that the wind shadow behind being much larger, the air has a forced entry through the windows to compensate for the lower pressure on the leeward side of the building. And this allows for even wind speed of 3 to 5 meters, which is the maximum wind speed most of the year, except during cyclones, when it can go up to 150 to 200 kilometers an hour. We managed to increase the wind speed in combination with electromechanical devices like fans to allow for a certain amount of comfort with ventilation. But given the fact that besides low wind speed, we have very heavy monsoons. The monsoon that we have two different monsoons. We have the summer monsoon, which is July, September, which comes in from the Arabian Sea. This monsoon is mostly raining late evening and in the night with high wind speed with the driving rain. But our main monsoon, where we get almost 70% of our rainfall, is in the winter, which is a returning monsoon over the Bay of Bengal in October to December. And this doesn't have driving rain. It does have occasional cyclones, 2 or 3 every season, but maybe once in a decade we have a super cyclone. This is a monsoon that you have to deal with because it can rain for 4 to 5 days non-stop in a steady rain. And during that time, the humidity level within the buildings goes so high that everything gets damp, fungal growth happens. You cannot leave the windows open. When you leave the windows open, you have a relative humidity inside the building that starts damaging all the interiors and the furnishing and the fittings and electrical stuff. So we have two different and contradicting propositions to deal with, which is increasing wind speed, except during those 2 months of the winter monsoon, but at the same time having control systems that can take 200 kilometers an hour cyclone that can also happen. So we have to do the landscaping around our building in such a way that we do not increase the ambient humidity. We have to work with heat island effect so that the rapid temperature drop between the daytime nighttime temperature happens, which is not easy in a high humidity zone. Allow for wind movement and also allow for windbreakers for certain seasons of the year. So you might almost say that it's an impossible task in terms of building profiles to take care of all these 4 different contradictions that happen. But one can have a certain modulated response. You will not have a perfect response to any one of these 4 challenges, but a certain modulated response provides for an adaptive comfort, both during the summer with higher wind speed, along with fans, during the monsoon with negative flow of air that prevents humidity from entering, and during cyclones, being able to seal off everything till the cyclone passes. And in the summer monsoon, during the night, when it's still very hot in June, July, to be able to cut off the rain, driving rain, and still have air movement coming into the building. And we do this not only with the building profile, but also how the buildings are placed on the site in relation to the air movement and the air movement. and to each other, but also how the building apertures are sized and shaped, so that you create pockets of trapped air during the daytime in the summer, which can be flushed out quite rapidly after 5 in the evening when the sea breeze starts, by manual manipulation of opening and closing of certain windows. And so we, of course, have to build up awareness of the inhabitants on how to deal with these openings. And under the roof, ventilation everywhere. In almost all spaces, we provide for under the roof ventilation, so that when we open the lower windows at 4:35 in the evening when the sea breeze comes in, the hot air rises and is flushing out before you start opening the leeward side windows to allow for the flushing through of the spaces. This goes, of course, hand in hand with shading, because ventilation is one thing, but heat gain through direct solar radiation. So the size, location, shape of the windows, along with the type of shading, has been looked into in all the directions. And wall shading, looking at, besides the orientation for the least solar gain, which means long facades are north-south, but during the summer, when the sun goes to the north, we may not need very long shading devices or long overhangs, but the ambient temperature is high enough that even with shaded walls, with open doors and windows, you do absorb a lot of heat through the air, through conduction rather than convection. So we need to take care of shading, not only of the walls, but also shading of the spaces around the building. Now, when all this is done, designed and done, one has to also check. So what we did, we undertook a 13-month post-occupancy data logging to verify whether the design interventions that we undertook actually had some effect. So in several places in the one of the clusters, we had sensors put in, and these sensors were for data logging for humidity, temperature, and lux when it was inside the building, to look at the comfort levels inside the building, and then humidity and temperature on walls which are shared between buildings, then wall surface temperature intake, so that we looked at the time lag between, the inside and outside temperature of walls and roofs. Based on that, in different locations of the building, east facing, north facing, south facing, we data logged on a daily, hourly basis for over 13 months. So outdoor conditions, which is not just in the building, but for the heat island effect. Indoor conditions, where the roof is exposed, where the west wall facing buildings, and indoor conditions where the roof is not exposed and it's east wall. And looking at a temperature range of 25 to 45 degrees with relative humidity of 30 to 90 degrees, outdoor conditions in June, September, December, and March, and indoor conditions of 28 to 38 degrees, again with 30 to 90% humidity. Taking that into account, this is what we found, that during the worst period, which is June, May, June for us, 22% of the time, we were in an uncomfortable area of the temperature and relative humidity. But for the rest, it was 50% of the time the outdoor temperature conditions fell in the comfortable zone, and 1% of the time it was in a very comfortable zone. But moving on, we see that between September, which is not such a comfortable month here because the relative humidity becomes pretty high after the summer monsoon, we had only 3% of the time uncomfortable conditions outside the buildings. December, March, of course, it's the best period of the year. Now, indoor conditions, we saw that for west-facing building with the roof completely exposed, that means you have heat gain on the western wall and you have heat gain through the roof. In June, 58% of the time, the indoor conditions were in the comfortable, which is 35 degrees centigrade, 30% humidity, to 31 degrees centigrade with 90% humidity. And in September, it was 80% of the time comfortable, and 20% of the time very, very comfortable. Same thing for the indoor conditions, which is ideal, which is east facing, and the roof is shaded. When we saw with just simple shading of the roof and not being exposed to the western side, from 58%, comfort level can go up to 75%. So basically, if one could avoid completely having unshaded roof, it would be ideal, but we could not avoid that. Moving on, now coming to the buildings. We looked at several aspects during design, which is the functional layout of the spaces and efficient building envelope design, building materials and technology, and the kind of building, how do you reduce on repairs and replacement. When we talk about building efficiency, one of the things that we take up as a challenge, not just in this project, but almost all our projects, is to see how to reduce single space, single functional use. And this is something that I find it's quite critical for architects to look at, because most of the time we label rooms in a building and then it becomes a space that is duplicated, because you, for example, you take the bedroom, you've labeled it bedroom, master bedroom, and it's dressing and bath and all that. But if you look at it, it's never used more than 25 to 30% of the life cycle of the building. And over and above, it has a lot of appliances and fittings and furnishing and spaces that are duplicated in the living spaces, in the family spaces, and other things. How do we actually design so that these single-use spaces can be reduced, can actually have multiple functions? The second aspect is, of course, the layout of this functional flow in such a manner that you bring in a drastic reduction of circulation spaces. Third, how do you actually juxtapose these spaces in such a manner that you reduce the amount of partition walling? Because more walls, more materials, more embodied energy. So rather than just going looking for the least embodied energy material, the first thing is reduce on the material use itself, reduce on the amount of space that is built, reduce on the need for circulation space, so that you start already with the minimal amount to be built. And if we take this challenge further, one of the things that we try to do is whatever is the functional space required by the client or the promoter, in the preliminary concept design, we try to reduce it by at least 7 to 10%. And then over a period of mutual learning process, try to bring it down by another 3 to 5%. So that an overall reduction of built up area comes to at least 12 to 15% at the end of the day. And the second thing that we go for is efficient building envelope, which basically means that how do you enclose maximum volume with minimum surface area? And this is a design challenge that is interesting as architects to look at. How do you actually create comfortable, aesthetic, functional spaces with the least amount of walls and least amount of footprint, so that at the end of the day, it's almost like you can contain a certain space and you can simplify it to a point that the envelope that holds that space, besides being proportional and aesthetics and functional, has used the least amount of material. And this is quite interesting as a challenge to take on, and it also has an impact on the comfort level inside, in a way that your heating, cooling, shading also comes down quite rapidly. Moving on to the building materials and technology itself, the main walling materials that we used was what we call poured earth concrete. This was actually something that the Auroville Earth Institute had been working on for a couple of years, and then we took this on as an applied research for this project to test out how we can use this construction technology and material to integrate construction and demolition waste. The composition of the poured earth is basically earth, sand, cement, and graded construction and demolition waste that is mixed in a concrete mixer and poured between shuttering, which you see here. This is the shuttering on the side, and the mix is made in a concrete mixer, poured into this shuttering, and when it's de-shuttered, this is the wall you get. So if you look at it, actually, you get a wall finish which is pretty good. It doesn't need any kind of, I would say, finishes afterwards, a putty or plaster or whatever. And the other material that we use is industrial waste. Kadapa district, which is not far from us, has a lot of mining going on basaltic stone, which is the Kadapa stone. After the boulders are cut and sliced, they're trimmed, the edges are trimmed to get rectilinear shapes. These trimmings are dumped on the farms of distress farmers. So we have been in contact with some of these factories buying the trimmings, and we use that as a walling material in several areas. We use it on the lower part, which is vulnerable to erosion during driving rain. We use it up just above the roofs also, again, where we would have driving rain, which could cause erosion. We use it just above the walls where concrete lintels and beams have to sit. And this is a waste material with very little skill. It can be used as a walling material, and it doesn't need any kind of finishing, and it actually gives, with the kind of, how do you say, deeper grooves, micro shading between each layer. And this is the final effect of a combination of earth and Kadapa stone trimmings. Finally, on all the roofing in the building, between the floors, because these are apartment buildings, and the intermediate floors are made of segmental arch vault. There's very little concrete slabs, and these are made of the local fired bricks, which are not wire cut. They're very poor quality bricks, but because of their porosity, they actually help also in reducing the reverberation of the sound and the sound carrying between one apartment to the other. And this is a finish. It's finished with stabilized earth mortar. So the segmental arches act as intermediate floor and the final roofing. The fourth material that we have used is recycled styrofoam, or what we call thermocol. Pondicherry has a lot of assembly industry, and of course in Auroville we generate a lot of packing material also, which comes with styrofoam. There is shredding machine that has been built in Auroville, which can shred in different sizes. So we have larger sizes for infill, we have smaller sizes for walling material, and so above the segmental vault, it's filled up with styrofoam, which acts as a lightweight filler plus insulation, sound insulation and heat insulation. And over that, the flooring is done for the apartment on the top. The doors and windows are all recycled wood. Unfortunately, the heritage part of Pondicherry is slowly disappearing, and the Madras roof beams and their door are being sold off. We keep buying them and recycling them into doors and windows. And the final part is, of course, the exposed roof. The reflective white tiles are third quality from a local factory where we have an agreement with them. They pile it up, and every time we need it, we go and buy it from them, so that even the distance of acquiring these tiles is reduced. Coming to the energy part, we have done three different things when it comes to energy. Because of the building shapes, the aperture location, sizes, and how they are placed, we reduce the operational energy needs. And we are also, because of the way the building apertures are placed in relation to each other, ensuring privacy, both visual and sound, we also reduce the need for screening between neighbors, so that you have constantly free flow of ventilation. And the third thing that we are doing also is reducing the glare by using mosquito mesh that keeps out the mosquitoes. and reduces the dust from the roads. When it's painted black, we actually reduce the glare. So we have diffuse muted light with free flow ventilation by the placement of the apertures, the building envelopes, how they're laid out, and the building, the footprint of the building on the site. This brings down considerably the operational energy needs. But of course, this is not sufficient. We still need to have energy. So we have grid connected PV, where we are generating sufficient amount of solar energy to meet our needs. So post-occupancy, we have been looking at what is an energy consumption, because we're connected to the grid and we're feeding in from the PV panel. We're looking at post-occupancy over 13 months, the average kilowatt per person in comparison to the ASHRAE standard, which is here 80 kilowatts. And we have been keeping consistently at an average between 35 kilowatts per hour, which is less than 50%. But then we looked at how positive we are. Even though we are way below the ASHRAE standard, we wanted to make sure that we are net positive. So basically our solar production, if you see, this period is a bit funny because in May, June last year during the lockdown, there was nobody maintaining the solar panels. So we had a drop in energy production because nobody was cleaning the dust on the panels. So you can see how rapidly it dropped. And then the energy consumption was going up at the same time because most of people were housebound and working from home. So the net positivity that we were looking at during this 13-month period, and it clearly shows the dips and falls based on the lifestyle and the occupancy rate. Now, moving to the second last part, which is the waste. So there are two different things that we're doing with waste. Sewage. The entire campus is connected to what we call a DWAT system. The DWAT system is actually capturing the black, gray, and the yellow stream all together, and it puts it through a biological gravity flow system where you have settlers and anaerobic filter. This part actually has been replaced now with what we call oh my God, I lose my words, but it's a vortex to because when the water has gone through this anaerobic system, anaerobic filter, what comes out maybe as per WHO standards quite good, but it has two different problems. It has got turbidity and it has smell. So previously we used to work with root zone to oxygenate the water, to remove the turbidity and fix oxygen, because by fixing oxygen you have clarity and the smell removal. But now we're using vortex to do that. And finally, the collection pond from where the water is used for irrigation. Presently, we are not reusing the treated water for flushing. Unfortunately, the treated level is insufficient to actually store it over several days to reuse it as the flushing water. But eventually we know that our technology needs to improve to bring it in so that most of the flushing water is actually from the recycled water. So we looked at water consumption. So this is the orange line is the urban water consumption as per Indian standard for minimum requirement. And this was our water consumption among all the inhabitants between over 13 months. We had, here we surpassed, but then we have been following through and it actually came down to about 114 to 120 liters per person. That is where the average is presently. We also looked at waste, solid waste generated. And so we have trained the inhabitants to segregate the waste into glass, mixed, plastic, paper, sanitary, and landfill. And the priority is that the landfill component is the least in terms of generation, so that every product that they buy and use to ensure that the waste generated is not of the landfill quality. And of course, then the next one is sanitary. And the final, of course, is glass and mixed. But reduction of plastic, sanitary, and landfill waste. We have been trying our best. In the beginning, as you can see with the spikes and dips, it was not very easy to convince them. But after almost 8 months, we start to plateau and start to have a certain amount of regularity in how the waste is generated and segregated. Finally, I'm going to come to the most touchy part, which is the lifestyle. Now, you see, after all these interventions, they are still kind of external and they're still somehow outside the intervention of the inhabitant. They have very little to participate except maybe how they use the water and what they do in terms of soaps and other things. But the inhabitants, we had a series of interactions and with facilitators and communication experts to build up several things. One is the geographical climatic awareness, because as I told you, we have people from 52 different countries of the world, each one coming in a psychocultural manner from very different climatic areas with very different cultural imprinting. So to get them to build up an awareness of how to live in a hot, humid, tropical zone. Then, of course, the sync with daylight hours. This is something that the entire country, especially urban India, needs to look into. How do we actually work with a rhythm that goes with the daylight hours? I see that work-life balance, which is a third thing, is very much connected to the daily routine and working with the daylight hours. Then appropriate and resilient clothing, avoiding of fast fashion. This being dressed to your geography and your climate reduces the operational energy needs drastically, reduces the water needs drastically between washing, both clothes and body washing, and further, at the source, it reduces the amount of water polluted and used to produce clothing. And then locally sourced food and plant-based diet, which goes in combination with the urban agriculture component that also brings in the use of treated sewage. And all this is, of course, possible with an equitable and tolerant attitude that goes with it, because you can be a perfect, environmentally sensitive human being living in a perfect house built with all the sustainable principles. But if you're a cranky and non-sharing individual, you're still not very sustainable. So with this, I'm going to finish my presentation. But before I go there, I would like all the participants to help us to achieve one thing. We have been trying to do this project for two reasons. One is we would like that as a country, we start looking at our national building code, not as a single country code, but actually on a regional level, that we have regional building codes. But to be able to do that, we have to have several projects in different parts of the country that starts benchmarking. But doing the benchmarking in itself is not sufficient. We have to then use this to convince the decision makers that this is a good idea. And as most of you as architects know, convincing decision makers means influencing them to recognize success. Now, recognizing success somehow, unfortunately, when it comes to architecture, like many other design and planning fields, is actually formal recognitions through agencies that evaluate you. So we have applied to an international organization that actually grades sustainable building, which is called Construction 21, which gives Green Solution Awards every year. And our project has gone through the first phase and has been nominated for the Green Solution Award. Now, I don't know why, but this is how the world works. The second phase is actually popularity voting. And I'm asking you all to vote for our project so that we can actually go to the jury level where we will have experts evaluating our project. So unless I go through the popularity voting, I cannot go to the professional evaluation. And Vaishali, who's one of the members of our extended Gooby group, has put together a very simple step-by-step on where do you go, which is the Construction 21 organization site, signing in, logging in, finding our project, and clicking on it and voting for us. Thank you.
Thank you so much. That was a wonderful presentation. And also thank you for sharing the process and the thoughts which goes behind in creating a sustainable and harmonious mode of development. I'm sure it takes a lot of time and effort in addressing every component of creating a sustainable development, such as material, land, water, waste, energy, and comfort. And along with that, also providing a validation for every step taken. It's incredible. I'm sure it sets a very beautiful example for us to follow how to create a sustainable development. So now I would request all of you to send in your questions you would like to ask.
There are no questions.
I'm sure I'm getting a lot of questions. So here we have questions. So here goes the first question is, they would like to know the materials which have been used in the building.
Okay. So going back to my presentation, we have done, let me go category. In terms of, as you notice, there are concrete columns. We had to go with minimal concrete columns because we're seismic zone 3 and public housing projects. We had to do it, and the funding came from the government of India. So we had to follow certain regulations. But the foundations itself, except for the isolated footing of the columns, is rammed earth foundation, which is basically you dig the trenches, you take out the soil, sieve it, mix it with some sand, 5% of cement by weight, ram it back in. The walling is made up of two different kind of materials. One is the Kadapa stone, which I showed in the presentation. These are strips of Kadapa stone, which is a basaltic stone from the state of Andhra Pradesh, from Kadapa district, a factory waste that we collect and use. And the second is poured earth walls, which is a mix of earth, 5% by cement by weight, and construction and demolition waste. Construction demolition waste is basically pieces of concrete, brickwork, screed, all these kind of things. It's graded from 40 to 50 mm pieces to down to 15 to 20 mm pieces, mixed in certain proportions in a concrete mixer along with earth and cement and a little bit of sand, like you do with normal concrete. And that's why we went for it, because with the skill development, we realized that there are certain processes that are already well established in the construction labor psyche. So they are used to working with concrete mixers. They're used to working with vibrators. But if you can just change it from concrete to earth and just allow them to just do a partial step-by-step skill upgradation while actually pulling back on the embodied energy by reducing the use of steel and cement, we would enable two things to happen: skill development in earth construction and reuse of construction and demolition waste, which is one of the biggest waste generated in urban India. Now, the problem is not just the waste generated by construction and demolition waste, is that they are being dumped. They're being dumped in low-lying areas. They're dumped in waterways, which causes flooding, which causes pollution of the groundwater. So in a way, our walling material is addressing two different things: industrial waste and construction and demolition waste, the waste component and the skill development, by linking it to ongoing construction processes. The roofing is made of segmental arches and bricks using centering. So I hope I answered your question.
Yes. The second question is, what is the comfort standard followed for the post-occupancy evaluation, which was done using the data logger study?
So what we looked at is that the comfort standard that we set We did not adopt the ASHRAE and other standards. We looked at three different things. How can people live with this climate with just a fan for ventilation? Additional, natural airflow, which means lowering the temperature with shading, and increase of wind speed with a fan and the kind of apertures that we have, so that you have evaporative cooling on the body. So we are not going to be achieving 24 degrees centigrade with 40% humidity, but we can achieve and have been achieving 30 to 32 degrees centigrade with 50% humidity when the outdoor temperature and humidity is at 38 degrees and 60%. So we can bring it down to 5 to 6 degrees difference. And this allows for an adaptive comfort. So if you're living in relative temperature of 38 degrees and 60% humidity outside, by being indoors at 32 and 40% humidity, you actually are able to live with just a simple fan. You don't need air conditioning. And this allows for people to have a biological immunity system that is in context with the climate and the geography they live in. We're not looking for comfort that is completely shut down, where you're isolated from the geographical and climatic zone that you're living in. But we're trying to have comfort that you can function and you can actually do things without suffering. And this is also combined with the other thing that I talked about is the activity time of the day and the type of activity, plus clothing and nutrition. You cannot isolate any of these four factors. Adaptive comfort comes with geography and clothing, food, and metabolic activity. And we try to target all the four.
Okay, so they would like to know what was the process of training the labor for using such innovative materials in the building.
Okay, so what we did was, you see, I don't know how it is in Delhi, Bombay, Hyderabad, or Bangalore. In our area, when you look at cost per square foot, people ask you to, they'll say, oh, if you're building with earth, is it lower cost than conventional building material? And we say, no, it's not lower cost. Why is it not lower cost? Because we try to tell them, look, in most buildings presently, post-reform India in the last decade, if you're spending X amount per square foot of building, almost 0.4x is labor and 0.6x is material. In our buildings, we are reversing it. We're saying 0.6 is labor and 0.4, let's say 40% is material and 60% is labor. Now, by providing for higher labor use in the building, we are doing two things. We are creating more job opportunity because the major resource that we have in our country is not energy or water or space or whatever, it's people. So first, create the market for employment. Then second is that start looking at what is the skill level that you have already in this market, in the labor that you're employing. Because if you're going to look at, many people in this country say, oh, we have to set up institutes that will do, specialized and systematic training of construction labor. Wonderful, yes. But most of the people who come as construction labor, the migrant, distressed migrant, have not even finished secondary school or middle school. Their reading and writing skills are minimal. They have to start earning a living as soon as they leave their home state. So you're not going to be able to bring them in and have supported training of 1 year, 2 years while their mothers and parents and wives and families are waiting for an earning, no? So what we have tried to do is basically say, okay, they have certain skills already from building their own homes, watching buildings being done, and a certain awareness of the different tools and technology already in the market. What are they? Concrete, shuttering, centering, mixers, vibrators, and walling in terms of putting up walls quite rapidly using bricks. So we said, just take the skill, now transfer it to something that gives a better quality finish and uses the labor as a larger component of building. So we went for poured earth concrete, where they have to grade the construction waste. They have to learn mixing of what kind of mixing and density by, you know, simple hands-on tests on the site, control of water, vibrator, and other thing, and using stone and other waste as walling material. With this, we have done two things, because you see, many of the times when we, I mean, since the last lockdown, when we had this huge exodus of distress migration labor, Pondicherry government, like many other state governments, are looking at providing housing for migrant labor. And I have attended several meetings with the local decision makers, both executive and political, where we talk about how do we provide housing for migrant labor. But actually, the question is not better design skills or better construction technology. Their main bottleneck is land tenure and access to capital. They are building our houses. They know how to build. What they don't have is place to build and to pay for the material needed to build. So everything else they had. So I cannot address access to land, land being a very touchy issue, but I can address access to building materials that they can use for self-building, which is construction waste, industrial waste. Access to this is possible through facilitated authorities for building for migrant labor if you also provide them skills for it. Excuse me. Yes.
So they would also like to know, how did you address the heat gains through the southwest facing roof?
Okay. Southwest facing roof. How did we address? We did two things. One is shading of the walls on the western side and the southern side. Southern side, when the sun goes to the south for us, it is during the cooler period of the year. So the air temperature is good enough so that we don't have heat gain through that through convection. But direct shading, direct sunlight is avoided with, as you can see in the picture that is up, we have roof shading all around the building. So, and the cantilevered part is calculated for the solar angle so that the roof is shaded during the peak period of heat gain, which is between 10:30 in the morning and 3 in the afternoon when the sun is overhead. But lower the sun goes in the western sky, in the afternoon when the air temperature is also quite hot, we are shading it with use of trees and vegetation so that the lower angle of the sun is actually broken by the shade of the trees, and we do not have either the ground or the building shading up. So of course this needs that the site planning is done very, very judiciously between the landscaping and the built environment. And the roofing itself has very good insulation. I showed you how we are doing the insulation. Use of styrofoam, and we're also using aerated concrete tiles, which is then covered with highly reflective third quality ceramic tiles.
Okay. So is it feasible to design organic shapes using the same building materials?
You can, I mean, anything can be done with anything, but what do you want to achieve? If you want, and I don't even understand, what do you want to achieve with organic building spaces? Because you see, it's all about the context. If the context demands that you have, I suppose by organic you mean spaces without corners and all curves and ellipses and ovoids and stuff like that. If that is required by design and not kind of whim of the designer to just say, look, hey, look, I can do curves. In that case, I don't know. You might need to look at other things besides, low embodied building material and question your concept of architecture itself. But if the space needed, or if the site needed to have a curved wall, of course you can make poured earth walls using faceted, or you can make curved shutterings. That's possible.
Okay. So they would like to know a reason why did you opted for arched roof instead of pitched roof, as because it's a high rainfall region.
Could you repeat that? I didn't understand that question.
So they would like to know the reason why did you use a arched roof instead of a pitched roof?
Okay, a vaulted roof. Okay. Why did I use a vaulted roof? For two different reasons. With this, I could reduce the amount of concrete needed in the building. The segmental arch roof, which is a vault on which is also an intermediate slab between the building, between the apartments, I can use low-fired bricks which are locally manufactured at, with sandy soil, in a manner that I reduce the need for cement and the amount of steel in slabs. If you look at the concrete slabs that are done, major part of the use is in the roofing. I have managed to remove it, so the internal roofing is all without concrete slabs. Second thing is that by having a vaulted roof, I'm able to give under the roof ventilation to vent the hot air from all the rooms. And third, of course, is that drainage on the final roof, because it's vaulted, the natural slope of the roof, I can drain the water into the overhangs, which also act as rainwater gutters, to then capture the rainwater and bring it down to my flow channels to harvest it in my bioswale as a secondary source of potable water. Okay?
Yeah. So we have a lot of questions. Let's pile it up with the last one. So what was the source of earth for the poured earth construction?
The source of earth for the poured earth construction was in two ways: the central sunken courtyard that you see, and the bioswale. And the second one was there is another water body that is being dug about 1.5 kilometers from our place, also to capture rainwater. And we've been sourcing the earth from them, because in several places in Auroville, we are working with rainwater catchment in ponds and bioswales. So we could get soil also from them. And we could get, because part of it is also the sewage treatment plant, so we could get soil from that too.
Okay. Thank you, Swasni, for answering the questions.
Thank you for hosting me. Yeah.
Before we end the webinar, I would like to make a few announcements. It is always interesting to hear case studies and get insight into the process, which is behind the outcome, in which we get inspired and have a lot of takeaways. And we would like to showcase more of these such success stories to really set the path to achieve the net zero goals for India. If you have something to share with us, or you have worked on a project, and if you have known about a project, please share with us or write us at nzeb@edsglobal.com so that we can feature it on our platform. We would also like you to join the NZEB Alliance. It is a network of innovators and early adopters of NZEB concept in India. The Alliance aims to accelerate the building sector towards the NZEB goals by providing an open forum for exchange of thoughts, ideas, and success stories. You can also sign up on our website to join the Alliance. All the webinars recordings are available on our YouTube channel. Their episodes are organized under the playlist for design, technology, policy, and skills. You can always access them on your YouTube channel. With this, we have come to the end of the webinar today. Hope you enjoyed the session, and I will see you all in the next one. Till then, stay safe, stay indoors. Thank you.